Hello everyone, this is Varsha from 4th Sem CSE AI Department, Sri Venkateswara College of Engineering. In this session, we will discuss about echolocation. Our agenda: echolocation, principle of echolocation, biological echolocation and its uses, and also technological echolocation and application and limitations of technological echolocations. Next, let us go with what is echolation. Echolation is a biological and technological phenomena used by certain animals and devices to navigate their environment, emitting sound waves and analyzing the returning echoes. Next, let us go with biological echolocation. What is biological echolocation? Biological echolocation is fantastic sensory adaptation that is found in certain animals like bats, whales, and some mammal animals that allows them to navigate and locate objects in their environment by emitting sounds and interpreting the echoes that bounce back. This ability has evolved in several animals to thrive in environment where visibility is limited, such as darkness or murky waters. We will see these biological echolocation especially in aquatic animals such as whales. Let us go with the steps involved in biological echolocation. The first step is emission of sound. The animals have some special organs to emit sounds. For example, in bats, we have mouth or noses. They emit ultrasonic calls, while in dolphins and whales, they produce clicks through specialized air sac in their blowholes. Animals which are capable of biological echolocation emit high frequency sound waves beyond the range of human hearing. The next step in the biological echolocation is propagation. The emitted sound travel through the air or water and spread out in all directions. In environment, when we have the prey or obstacles, these waves encounter the objects. Next, let us go with the reflection and detection. When the sound waves strike an object, they bounce back as echo. Specialized sensory organs such as ear for bats or lower jaw for dolphins and whales are designed to detect these echoes. Next. Next step is interpretation. The returning echoes provide crucial information about the object's distance, such as size, shape, texture, and movement. Animals analyzing the time delay between sound emission and echo reception, they find in frequency and intensity of. Do you ever think how bats can identify the prey in the darkness? They use the principle of echolocation. Animals use the information from echolocation to navigate their surroundings, avoid collisions from obstacles, and locate prey. For example, bats can detect tiny insects in complete darkness and catch them mid-flight using their echolocation abilities. Dolphins and whales use echolocation to find school of fishes or other. Next, let us see how does biological echolation works. Firstly, underwater echolation. Marine animals like dolphins use echolation to navigate complex underwater environment. Next, bats. As we seen before, aerial echolation. Bats also use echolation to fly through the night and catch prey. Next, when we go to the sonar in whales, whales uses sound waves to communicate and navigate the ocean. Next, technological echolation. From seeing the echolation principle in animals, we developed technological echolation, which helps us in many applications. Let us see the steps in technological echolation. First step in technological echolation is also signal emission. In biological echolation, the animals have special organs. Here we use some laser lights, radio waves, and artificial machines which emits sounds. A technological echolation system begins by emitting a signal which could be sound waves. In case of sonar or ultrasonic sensors, radio waves are laser light. This emitted signal travels through the environment and interact with the objects in path. Next, propagation. The emitted signal propagates through the medium at a known speed. The speed of propagation is crucial for calculating distance based on time it takes for the signal to return. Next, Reflection and echoes. When the emitted signal encounters an object, a portion of it is reflected back towards the surface. This reflected signal is referred to as an echo. In animals, to capture this echo, we have special organs like lower jaw, lower jaw in whales, and ears in bats. Here we have some sensors to detect this echolocation. This reflected signal is referred to as an echo. The time delay between the emission of signal and reception of echo provides information about the distance of the object. Next up, reception and detection. Specialized sensors such as microphones, antennas, or photo detectors are used to detect and capture the echoes. Next, interpretation and analysis. By analyzing factors such as time delay between emission and reception, thus frequency shift or Doppler effect of the returning signal and intensity of echoes, the system can extract information about the object distance, velocity, size, shape, and sometimes even its material composition. Next, data processing. The collected echo data are processed using algorithms to create visualized representations, maps, other forms of information about environment. Advanced signal processing techniques are used to filter out noise, enhance signal quality, and extract meaningful data. Overall, we can say that technological echolocation revolves around the emission and detection of signals, analyzing of returning echoes, and extraction of valuable information about the surroundings. This concept has led to the development of diverse technology that having a significance on fields such as navigation, robotics, defense, environmental monitoring, and more. This is very much useful in navigation. Next, let us go with the application of technological echolocation in medicine. It is used in ultrasound imaging. Ultrasound technology uses high frequency sound waves to create real-time images of internal body structures. This commonly used for imaging organs, monitoring pregnancies, and guiding procedures such as biopsies and injections. These are safe because they are non-invasive. They don't use any injection or any hurt to the body, and the picture is visualized clearly. They are used in cardiology, radiology, and more. Next, Doppler ultrasound. Doppler ultrasound is a variation of ultrasound that uses echolocation principle to access blood flow and detect abnormalities in blood vessels. It helps in diagnosis condition like arterial blockages. Next, echocardiography. Echocardiography uses sound waves to create images of heart structure and function. It is vital for diagnosing heart conditions such as valve disorder, heart murmurs, and congenital heart defects. Next, intravascular ultrasound. IVUS involves a placed miniature ultrasound probe inside blood vessels to provide detailed image of vessel walls. Next, let us go with the three-dimensional imaging. The echolation is also inspired like three-dimensional ultrasound and 3D echocardiography offer enhanced visualization and better understanding of complex anatomical structures like anomalies. Next, it is also used in elastography. Elastography uses echolation principle to access tissue stiffness and elasticity. Next, fetal monitoring. Continuous wave Doppler ultrasound monitor fetal heart rate during labor and pregnancy, ensuring the well-being of fetus. Next, intracardiac echocardiography. It is used to insert heart to guide catheter-based procedures like ablation and repairs of structural defects. Next, blind navigation aids. Echolation principles are also applied in developing navigation aids for visually impaired. Wearable devices emit sounds and provide feedback about nearby obstacles, enabling mobility. Let us go with the application of technological echolocation in robotics. It is used in assembly lines. Radar and sonar sensors can be helped to use robot assemble complex products on the factory floor. Next, let us go with the cleaning. Roomba and other cleaning robots use echolation to navigate spaces and map out room and obstacles. It is also used in military technology. Drones and other defense technology use ultrasound sonar technology to find critical information and gather intelligence in battlefield. Next, Potential limitations and challenges of technological echolocation. Data processing. The data collected during echolocation need to be processed by powerful computers, which can be slow and expensive to manage. Next, interference. Echoes can be distorted by the environment, making it difficult for sensor to accurately detect objects. Next, energy consumption. Devices that rely on echolation can be energy intensive and require powerful batteries, limiting their remote or inaccess. Let us go with the future developments and advancements in ecological technology. First one is miniaturization. Researchers are exploring ways to make echolation technology smaller and more portable so it can be used in remote locations used or applied to new field like agriculture. Next, artificial intelligence. New AI systems can help sensor better interpret and analyze the data collected during echolocation, leading to more accurate and efficient detection. Next, new sensors. Scientists are exploring new types of sensors that can be used in echolation, including electromagnetic radiation and light waves. Thank you.